Hello, my name is Rob Durham,
And I'm John Chappell.
and you're listening to another episode of the Gyrolab Spin. On today's episode, we're talking about advanced assay development. I think one of the advantages of the Gyrolab system is that it's an open platform and that you can really develop your own assays quite easily.
Yeah, and I think this is the highlight really, of the speed of assay development and how it's a really open, flexible platform that you can really use basically any way you want to use it. And we really want to help you develop your own assays. So the agenda today is really about assay development, and this was inspired by some workshops that we've had at our Gyrolab user meetings. So we'd like to thank Nina, Linda, Eric, and Anne Eccleston. I mean, all of them have really helped to get the material together and put a kind of a presentation that really kind of shows the power of the platform and some things that can really help to develop methods.
Yeah, and it's been a real advantage at our Gyrolab seminars to have these workshop materials available to help customers speed up their assay development workflows. And so what we wanted to do today was to bring a little bit of some of what you get at a Gyrolab workshop to the podcast.
Yeah, I mean, I'm probably one of the biggest advocates within Gyros Protein Technologies of the user meeting and the importance of getting feedback from users and to really help them. So I think it's a really good opportunity to give this material to a wider audience through the podcast.
Yeah, but still encourage folks to get to a user meeting that's hopefully coming near you so that you can join us in person. We'd really love to have as many people there as possible.
Yeah. So today, really, we want to go through general assay development, kind of some, the kind of the development guide, how you start approaching an assay, things like choice of CDs, methods, etc. And then really how you can customize the method. So we're going to go through this in detail today.
One resource I'd like for folks to know about is we have a Gyrolab immunoassay development guide that you can download from the user zone. It's in a PDF format. You can also use this link at the bottom of the screen here to go directly to download a copy of the instrument development guide or the immunoassay development guide. And this really just walks you through the steps that we'll cover today in some detail. But it's a great overview for folks that want to have it handy when they're working on their own assays.
Yeah, I know a lot of customers have this printed out and even on the wall next to the instrument, so it can be very handy. So it's a really useful guide.
So when you take a look at that user guide, that assay development guide rather, you'll see that there's 7 basic steps that we're going to go through. And while assay development is probably the same the world over from an immunoassay perspective, working on a CD-shaped assay plate creates some differences that people have to think about when they're doing that. And so we'll walk you through how to pick the right assay format, what buffers to use, and on the CD that's a bit more challenging simply because the Rexit buffers can have an impact on how the assay performs on the CD. We also will want to identify the right reagents, test those reagents, titrate your capture detect as an example, and then test different matrices to make sure that you have an assay that works the best for the particular CD type that you're working with.
And it all depends on what analytical range you need, what sensitivity you need. So I mean, you could, go for a low sensitivity or a high sensitivity method depending on what your use is. So I think there's a lot of flexibility. The same assay can also be switched to different CDs to give you a different range. So, for example, I've had a situation where I developed a very sensitive method. And then when it came to analyze samples, we had to analyze dilutable samples, like thousands fold. So that gives the option to desensitize the method.
Yeah, and I think, it's not lost on folks, I think, the fact that if you have to do a very high dilution of your samples, then you're multiplying whatever error is in your method by the dilution factor. So it doesn't take a very large dilution before you have the chance to introduce a lot of extra error in your method.
As has been stated before, very much is an open platform. It can support many different assay designs, so whatever assay format that you want to run is possible. Anything from sandwich assay to PK assays, bridging assays, indirect assay formats. I mean, you can have a one step where you pre-incubate everything offline and then you add it as a one step onto the system. You can have a two step, which are like a normal sandwich assay, three step, four step, five step. So you can have a double capture, double detection. There's things like slow spin, fast spin. So there's a lot of options in how you can develop methods.
Yeah, there's a lot of flexibility in the system, and on our system, what we call a method is sort of the automated protocol that the instrument runs through, and so that defines the CD, the number of steps, how you want to set up your assay. Even if it's something like an affinity type, is all defined by the particular method that you're using.
And then the user zone has different method options. So there are options that are available to customers, but also there are options available to field application specialist scientists to actually as further options. So we always encourage you to talk to your customer support to see what is available based on your end user requirement.
Yeah, I think the message that I've always given to folks is that if you think you need a modified method to do the type of assay that you want to do on the Gyrolab system, I believe it's certainly possible, but always work with the field application specialist or scientist in your area, because they'll have the latest information. They'll also have access to experimental methods that might be useful for your particular problem.
Yep.
So here what we're trying to do is summarize the assay development steps. And so you're going to want to choose and screen the right reagent candidates. And again, this is a step that's can be very onerous in a plate-based method where you have 4 to 5 hours between experiments to determine whether and which reagent combinations are best. Once you've identified your best binding pairs, which in the gyro system can be done very quickly, we've got examples where folks have screened 10 or 14 different pairs of antibodies in an hour. And that's certainly a much faster method than doing it on a typical plate-based method.
Yeah, because the instrument automates the steps, so you just need to place all the antibody in the plate, and then the actual system will add it to all the different wells. Because when you're doing checkerboards, it's very hard. It's very easy to make a mistake in terms of where you're pipetting, but it's so easy to develop an assay on the Gyrolab because of this flexibility.
And I think a number of, we'll maybe think about it for a different podcast, but it would be interesting to talk to somebody who's really implemented a DOE and, where they've done, more advanced statistical methods to sort of optimize quickly based off of 2 or 3 different parameters simultaneously. A multifactorial design of experiments is possible.
Yeah, the Gyrolab can be easily combined with the DOE up front to design the experiment.
Yeah, and based on your checkerboard experiment, I can think of many times I was in the lab doing just that, a checkerboard experiment with a bunch of different options, and then somebody comes and talks to you while you're pipetting.
Yeah, that never happened.
Yeah, it's awful, so then you're like, did I do that or not? And so again, the nice thing about the gyro system is that it doesn't care whether you talk to it or not while it's pipetting. It's going to do what you told it you put in the plate. And next up would be sort of once you've sort of found the right pair, then you can optimize the reagent concentrations. Typically we'll often saturate the column with the capture reagent, but there might be some situations where that's not necessary, or it's not the ideal situation. And then lastly, you'd want to titrate the detection reagent concentration. Typically we'll have something between 5 and 50 nanomolars for detect to give us the best performance of our assay.
Yeah, I mean, it's useful to use the viewer profile as well and look at the binding. So for example, if you find that everything is binding onto the top of the column, then you might want to look. You can add something like biotinylated BSA to kind of spread it across the column. So the viewer profile is very good way of viewing what's happening in the binding in the assay.
Yeah, and I think we've spent some time talking about how the viewer is used in one of the previous podcasts, but certainly it's one of those things that's a constant that folks use to help with both assay troubleshooting and assay development. Once you've sort of got your optimized reagent conditions, then you'd go on to testing matrix. And I think this is one of the real highlights of the gyro system, is that we're able to work in up to 100% matrix, and that's proved to be a real advantage for situations where you want to look at things like free and total. And then once you've tested out your matrix and established what your MRD is, then you'd want to choose the sample, the CD volume. And that you alluded to this earlier and said that, you know, depending on where you need to go with the analytical range of your assay, it's a simple matter to shift from the 200 nanoliter CD to a 20 nanoliter CD if you want less sensitivity or dilute your samples less, or if you need improved sensitivity, the addition of the 1,000 or the 4,000 nanoliter CD gives you lots of options to select the right analytical range.
I mean, a lot of people will start developing using the 200 CD, mainly because there's more wells, so therefore they can screen more conditions, and then they will then move maybe towards 1,000 or 4,000, depending on the assay requirements.
Yeah, and then as you would in any assay, you could do some spiked samples, recovery, parallelism studies. Those would be the next thing once you've sort of got your analytical range nailed down.
So now really we want to focus on some less common assay formats and some of the unique challenges associated with them. So we want to look at the two-step assay format where you pre-incubate the capture and the analyte, and that seems to be quite effective for quite a few assays. And also competition assays, which we've done quite a few of over the last couple of years. So I want to give you some tips on competition assays.
So one of the things we want to try and do with a two-step format is to give more time for the capture and the analyte to interact with one another. We'll use this in situations where maybe you don't have a very rapid on rate for the capture reagent that you're looking at, and in order to get the assay performance that you're looking for, you need a little bit more time for that incubation to occur. So in the gyro system, you have the flexibility of doing that in an offline format. So now, what we're pointing out here in the circle above is that the common reagent channel normally is used to add your capture reagent, and you would use 200 nanoliters of capture. And in a typical assay format, you're going to want to saturate the column with capture reagent, so we use a relatively high concentration, low volume. Now when we mix the capture reagent with the sample up front, we'll probably back down on that capture concentration because we want to sort of match more closely with what the analytical range of your assay is going to be, and you want to pick a concentration that's probably equal molar capture with the top concentration of the analyte that you're trying to capture out of your situation, out of your sample.
I mean, it's key that the actual concentration then is very critical, which we'll actually show in the next slide.
And then, so again, you can flip this around and do it in two flavors. So you can do capture reagent, analyte incubation. You can also do a detection reagent, analyte incubation. The two different flavors of capture reagent there, and then you can see based off of the different sample formats or CD types that you're going to run, then you might want to adjust the capture concentration that you're adding, because now we're using the sample chamber to add our capture reagent, so you're going to add relatively more volume according to the amount of sample that you put in there.
So here's some great example data of what we're trying to say. So where we've pre-incubated the capture and the analyte prior to the assay, the actual concentration that you load onto the CD is much more critical. You need to ensure that you have enough material and that the peak isn't too narrow, So if you go too small in capture concentrations, it'll all bind on the top of the column. And if you go too large in concentration, you start to have a lot of unreacted capture that binds to the column, so you get a very broad profile.
Yeah, and you can see that here in the images that we're showing with the 0.5 versus 5. You can begin to get a sense of that radial spread that you're seeing, which tells you something about the binding profile of your analytes, which you don't normally see in a typical plate-based system.
Yeah. So now moving on to competition assays, and it gives me great pleasure to discuss competition assays. I started my career many years ago doing radio immunoassays, particularly where analysing small molecules, when small molecules now are mainly done by LCMS, but it's nice to see that small molecules can be done in the Gyrolab format. And
yeah.
I'm a big fan of the mixing CD in particular, and this is another use of the mixing CD outside the normal use of it for ADA assays for acid dissociation.
Yeah, it really automates that process of adding your reagents together and giving them some incubation time, and then using the same column chromatography to do your affinity purification step.
Yeah, and I think we talked in the previous slide about pre-incubating the capture and the analyte. Another way to increase the contact time of reagents is to use the mixing chamber to allow the reagents to bind to each other. And we're very flexible on time. You can alter the time of incubation and mixing, so you have a lot of flexibility. So, but in terms of competition assays, you normally do a competition assay when you have a small molecule and you only have one antibody is normally the reason. So you need then a labeled and unlabeled version of the analyte, and then you're effectively competing that against the single antibody. So in this case, we've actually tried two assay formats. So where we have the antibody on the column, and then you pre-incubate you compete the analyte and the labeled version. You can de-equilibrium the reaction by pre-incubating the unlabeled first and then add on the labeled. That sometimes improves sensitivity. And what we also have done is have the labeled version on the column, and then we pre-incubate the analyte and the antibody offline and then run it over the column. So there's a lot of flexibility. The thing about competitive assays, we have finite reagents rather than excess reagents. So this does change how you actually set the assay up. So if you want to set up a competitive assay, I would suggest that you contact your field application scientists, and they can really help you.
Yeah, and I think this assay format really is along the same lines as the affinity measurement on the Gyrolab as well. It's just a similar assay setup and design. So again, if this is something that's new to you, we can certainly have some technical support help you implement this in your lab.
Yeah, I think really just want to show that these assays are possible. Customers are using them, so the system has a flexibility to run this assay format as well.
So here we talk in detail about how things work on the mixing CD, and so again, you have this automatic sequential addition of samples, reagents to the mixing chamber. The beauty of this system is it allows you to volume define, add samples in 200 nanoliter increments into the mixing chamber, allow that to incubate for a period of time, which you can modify very easily in the method. It's a method modification that's designed to be changed, to be optimized. And then once the incubation period is over, it will do a very hard spin and overcome that thicker hydrophobic barrier at the bottom of the mixing chamber, and then pass your sample that's been incubated over the streptavidin column.
Yeah, and you can pre-coat the column, for example, and then run the mixture over the pre-incubated column, or if you'll have your capture pre-incubated and then the whole mixture will run over the column. So it gives you a lot of flexibility in terms of assay format, and you can really crank up the incubation times as well. So you can take a normal 1 hour assay and you can really increase it depending on the requirements of your assay. But we have seen people achieve with low affinity reagents, which normally require an overnight incubation, they can achieve similar sensitivity in a couple of hours using the mixing chamber.
Yeah, and I think the one limitation or difference that you have to sort of wrap your mind around with this is that you don't have the flexibility to have different volumes being added to the mixing chamber. It's a 1 to 1 to 1, 200 nanoliters each addition. Up to 4 different additions will fit in the mixing chamber, but you're still with that fixed 200 nanoliter add.
Yeah.
So one of the other steps that you think about in terms of your assay development on the Gyrolab system is to pick the right CD. And so next we'll turn our attention to which CDs you pick and why.
Yeah, and then, I mean, as already stated, this gives you a lot of flexibility, and you can really tailor your assay depending on your assay requirements.
So here what we're going to delve into is a little bit more detail on selection of CD type. So you can see here across the 4 basic different CD types we have are really derived based off sample volume from 20 nanoliters all the way up to 4,000 nanoliters with the new addition of the 4,000 nanoliter CDs. We talked a bit about the mixing CD, and again, that's the equivalent of a 200 nanoliter CD, so that would sit kind of in the range where that orange curve is down below. And what you see with just changing the sample volume, thinking about sample volume specifically, is that you're going to shift the analytical range of the assay from left to right as you increase the sample volume that's going on with the same 15 nanoliter affinity capture column.
Yeah, and I'm a big advocate for the high capacity beads as well.
Yeah.
Having done a lot of work trying to develop free assays where we need to use 100% matrix, and that works very well on the high capacity CDs in particular.
Yeah.
4000 HC, 1000 HC, and the 20 HC, or you can take the same assay in 100% matrix and give you a completely analytical range in neat matrix.
Yeah.
And it's good for low affinity reagents as well, where you need a higher binding capacity. But it doesn't necessarily mean higher sensitivity, which is one of the sometimes surprises me. But because it's it's different reaction kinetics going on the CD basically.
Yeah, and I think given that advantage for free measurement or in 100% matrix, that's caused some customers to be really interested in having another 200 HC CD. Yeah,
it's in request.
Yeah, we know some customers that are really interested in having that 200 HC to round out the whole family of CD types. But I think one of the things that isn't easily appreciated until you sort of look at across all of the different types of CD, as you can see in the upper right-hand figure above us here, using IL2 as an example, there you can see that if you compare the standard bioappy CD to the HC CDs, in this case we have the 20 HC and the 1000 HC on this graph, the thing that jumps out at you is that increased background.
Yeah, the background doesn't appear when you do 100% matrix. Actually, you get less background with high capacity.
Interesting.
So I think it's about the right selection of CD for the right assay, and depending on what assay range you need.
Exactly. So here we're illustrating the Gyrolab bioappy 1000 HC and 4000 HC toolbox. These are because of the comments John made earlier about the utility of these CDs for 100% matrix and or their use in bioprocess sample types or bioprocess applications. This gives the end user the flexibility to get a kit that contains the CD and some wash buffers that are useful for a variety of different applications.
Yeah, I mean, these toolboxes are mainly used by a bioprocess developing HCP assays. But one thing that this toolbox do contain is this wash buffer duo. And this wash buffer duo can actually be useful for other assays as well. So it's worth discussing with your FES because that is another option for you. And to highlight this, we've shown an example where the wash buffer duo that's available with the toolbox has been used, and and you can see with the graph on the right The red curve is the normal with the normal wash, and then when we've introduced the wash buffer duo, this has significantly reduced the background in the method.
Yeah, and I think this highlights one of the real differences sometimes with the Gyros system is that buffer can make a huge difference in assay performance, both with the background and then also the way the samples and reagents flow on the CD. Unlike, as a wash buffer in an ELISA type example, that doesn't have as big of an impact necessarily on assay performance.
So just to highlight what we said on an earlier slide, this just shows you for a free assay that we've developed on different CDs, and you can see the effect of the analytical range moving, from 20 HC all the way to 4000 HC. You can then understand why people may request the 200 HC to complete the assay range.
Sit there in the middle, just that gap just drives some people crazy, but I think for the most part, you see quite a lot of overlap. If you drew the analytical range between that red curve on the right and the blue curve in the middle there, you can see that there's a significant overlap. So you're not going to miss a lot without that 200 CD today.
And all these curves are in 100% matrix. So this is really for free measurement.
Yeah.
So this really highlights the advantage of the high capacity CD for 100% matrix. Mm-hmm. You can see with the 4000 CD, when we look at the neat matrix sample, there's a huge area, sort of a matrix effect going on, and there's a lot outside the integration area of the viewer profile. Yeah. And as you dilute the sample, you can see that this is starting to be diluted out. So if I was to use the 4000 CD, I would apply a minimum of 1 in 4 dilution, mm-hmm. Which obviously for free you may get dissociation of the complex. So obviously it may not measure free, but when we look at 100% matrix on the 4000 HC, you can see the matrix really is not having any impact, and you can actually measure 100% matrix through the CD. We theorize that some of the matrix proteins are being trapped in the more porous beads that appear in the high capacity CD, and the matrix proteins having less interference on the assay binding.
Yeah, this is really a nice example of the flexibility of having that HC CD available. It's really enabled this neat matrix work and allowed customers who are concerned about free 100% matrix, allowing them to do their work without worrying about the equilibrium shift that will occur once they dilute those samples. So we'll talk now a little bit about some customization things that can be done to help facilitate your assay development on the Gyrolab system. And we talk about this with a little bit of caution because the methods themselves are relatively locked down, and modifying methods is possible, but it can create some unwanted consequences. So we would really encourage folks out there that have a method that doesn't do everything that you want it to do to really work closely with your FAS to help you modify the methods to meet your needs.
Yeah, I mean, there are complex microfluidics going on with the centrifugal force, etc. Please do not play with the spin speeds and things, because that can really talk to your FAS or your or support to really help you.
Exactly.
Further to what we're saying, the user zone contains the methods that you may want, anywhere from 1 step all the way up to 5 step, with all the classical configurations. Also, some methods are available only to the FAS, and these are actually, they can be seen in blue here. So the FAS can actually provide you additional methods, things like slow spins, also things like additional wash solutions. So that, there are a lot of flexibility methods that can be provided to you.
Yeah, and I think the message here is we're not trying to hide anything or prevent you from utilizing all the parameters that are available to modify your method and produce a result that is acceptable. But we just recognize too that there's so many things that can go wrong and can create unwanted problems, and we've observed these many times over the years. And so
Yeah.
we're with caution telling you to sort of work directly with the FAS. That's what they're there for,
Yeah.
to help you get the most out of your system.
Yeah, I mean the standard methods will work for 90% of the time, but
Yeah.
we are catering for the 10% with awkward. I mean, this is the joy of immunoassay development. Sometimes you get tricky molecules, and
Yeah.
we're here to really help you with these tricky
Yeah,
methods.
the easy molecules have all been done already, John. I think we only
Unfortunately,
need the hard
yes.
ones now.
Yeah, but it makes life interesting.
Exactly. So some of the typical method customizations that you'd run into is oftentimes in the original assay development, we'll run at 3 different photomultiplier tube settings. PMT is really the gain setting on the detector, and so you may not need all 3, and oftentimes we'll just exclude or delete a couple of those so you don't have extra data sitting around. So you can remove those unused PMT settings to streamline your method a little bit. It saves about 6 minutes of time in the method as well.
I mean, some of the other kind of things you can modify, as an example here, is needle overfill. So we have this situation where samples are not necessarily homogeneous, and they might sediment. So you can actually add an overfill, which will effectively increase the mixing as part of the dispensing. And also you can actually add a specific mixing step. So we have a situation where you get the instrument to pre-mix the sample. The needle will go up and down within the sample and pre-mix it before it's dispensed on the CD. So this can help in certain situations.
Yeah, it's one of those that we've seen with a specific analyte where there was non-homogeneity of the sample from the time the plate was produced and it sat in the CD, sat in the instrument for a period of time, and then you see that things are starting to settle out into the bottom, and you get this replicate variability that was difficult to solve until you did this mixing step.
I mean, the other thing we've been asked to do a lot is that extra needle washes, particularly when we've had some really tricky analytes, things like nanobodies. And adding additional washes may help actually improve the assay.
Yeah, exactly. And again, that can all be done, but there are some real considerations for impacting the way the system runs. So again, we urge folks out there who have this need to reach out to us, and we'll be happy to engage you and make sure that you're getting a method that will do what you want without the unexpected consequences or errors that might interfere with your ability to do the work. So here's an example which really illustrates what we were talking about, where typically you see this replicate variability between replicate 1 and replicate 2, and you'd say, well, let's play around with the diluent, the buffer that we're diluting our samples with, and you can see that it's shifting from the Rexip AN to the Rexip F seem to help a little bit, but we're still seeing this trend in the wrong direction. And so what we then did was add that increased overfill, which mixed the samples a little bit, and then you can see the final result here, where now those replicates overlay one another as you would expect, and we see that we get really good precision between the 2 replicates, and it fixed the problem. So again, this is an example where the customers worked closely with us to develop a method that no FAS or no user would modify in the field. We had the R&D team in Sweden come up with this overfill method, fix the problem, and customers able to go ahead and utilize the system and really have a much better assay.
Yeah, and it gives you a lot of flexibility. There's things we can do to solve very complex problems.
Well, that brings us to the end of another episode, John.
Yeah, thanks, Rob, and it's been fun, and it's an interesting subjects we've discussed today, and hopefully they will be useful to the folks out there. Again, please contact us with any suggestions of future podcasts. Contact us on the email addresses as indicated on the slide.
Yep, and also for sure, if you're having any of these issues, please reach out to John or I or your local field application scientist who can help you modify a method or work through the troubleshooting to help you get the most out of your assay development on the Gyrolab. So with that, I'll say that's goodbye from me.
And it's goodbye from him.
Yeah, and until next time.